So hello everyone, how are you all? I hope you all are fine and safe. Well again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which what we are gonna do, it's not visible in front of you all, right? But soon will be. Here it is. The incredibly very crazy looking thing which represents sine theta over theta as an infinite product. And you know what? It is evident that it's gonna take a lot of time to be proven, and the method that the method by which I'm going to prove this is really difficult, and it's really lengthy at first, right? It's really lengthy actually. And firstly, let me just tell you something about this. So this is Euler's infinite product that represents sine function actually, right? Okay, so pretty fine. And you know what, this is really difficult to be proved actually, but still we will do this in right today. And you know what, it's perfectly fine that we are on tablet rather than on me just on the board, because if I'm going to be just prove this down on my boards, so that's gonna be ended up by taking my life. So that's why I just chose this way to prove this down, right? Okay, so I just want you to just be patient, because it's gonna take a lot of time to be proven, and you just have to understand each and every steps, right? To understand each and every steps, you just have to focus, right? Okay, so I think we should begin from here. So basically, I'm just going to begin the proof by just marketing one of my videos in front of you all. Okay, so basically, I think not that much earlier, but yeah, it's pretty, I think 2-3 weeks ago, I have proved that sine of a plus b was sine of a cosine of b plus cosine of a sine of b. And you know what, I have proved this identity using the most famous Euler's identity, that says Euler's formula actually, e to the I theta plus I times sine theta. E to the I theta equals cosine theta plus I sine theta. Okay, now I'm just looking to plug here a equals b equals theta. So basically we are talking about sine theta plus theta. So if we just replace a b here with theta only, so that's gonna give us sine theta cosine theta plus cosine theta sine theta. So basically on the left hand side we are having sine of 2 theta equals, and when we add them up, so that's gonna give us 2 sine theta cosine theta. Okay, so yeah, this is really amazing like identity of double angle actually. And well, nobody just proved this down, because everyone just uses it as an lemma or as a lemma, but I have proved this down in front of you. Even we are talking about the longest proof, I think. So yeah, it was necessary, because to build up some foundations in front of you all, and we are just going to begin our proof with this formula only. So that is why I've just proved this down in front of you. But if you want to see the total proof thoroughly, so you just have to go through on my channel, and you just have to search it on that, like on that platform you would have that. Okay, so now in this video, in this relation, we have to talk about sine of theta only. So that is going to represent 2 sine of theta over 2 cosine of theta over 2. Well, we have just replaced theta here with theta over 2 both end sides. That's it. Okay, so it's pretty evident that this part, we are having this part here on the left hand side, and we are going to just keep that left hand side part till the end of the video, right? but we just have to prove all these things to that big chunk of things like this one and this one. Okay, now we don't need to just waste our time here. We just have to prove this down as fast as possible. Okay, now there is another property that says cosine of theta over 2 is equals sine of pi over 2 plus theta over 2. So yeah, again we are just going to plug that down on the place of cosine of theta over 2 here. So that's gonna give us sine of theta equals to sine theta over 2 and it's sine of pi over 2 theta over 2. Yeah, it's pretty fine. Okay, and now we are gonna play with the further expansion of this function and the further expansion of this one also. So I think I should just consider just taking this in a parenthesis here itself, because it's as a first equation. Okay, now let's further factorize sine of theta over 2 with the double angle formula. So if we talk about sine of theta over 2, so that's gonna be factored out to sine theta over 4 cosine of theta over 4, and cosine of theta over 4 can be written as sine of pi over 2 plus theta of theta over 4. So basically this is sine of theta over 4 and then sine of pi over 2 plus theta over 4. So now we can say that sine of theta over 2 equals to sine theta over 4 and sine pi over 2 plus theta over 4. Okay, so yeah, here it is. And next, if we talk about this factor, so let's just factorize that further. So that's gonna give us sine of pi over 2 plus theta over 2, right? So that can be written as 2 sine of pi, we can write this as pi plus theta over 2, right? Well, this argument over 2 here, right? So you can understand that, and times the cosine of the same argument, that is pi plus theta over 2. So again we can just write that down. So sine of pi plus theta over 2 can be factored out as 2 sine of pi plus theta over 4, and then it can be written as sine of pi over 2 plus pi plus theta over 4. Now again we're just going to plug this back in the first equation and let's see what we're having here. Okay, so basically I'm talking about, let's just plug this result here in this one and this result here in this one over here, right? Okay, so now let's just plug that over there. So let's see what we're having. So basically we're having sine of theta equals 2, we were having it earlier, and sine of theta over 2 can be replaced with 2 sine theta over 4 and sine pi plus 2 pi over 2 plus theta over 4 times 2 sine theta over 4 and times sine pi, oh wait a second, yeah, pi over 2 plus theta over 4, and then we can write this down, this one, as this thing, this big chunk of thing here. So that can be written as times 2 sine of pi plus theta over 4 and then sine of pi over 2 plus pi plus theta over 4 here. So basically if we combine all these two factors here, so we can say that sine of theta equals 2 to the 3 and times sine of theta over 4 times sine of, we can say that it's pi plus, oh wait a second, we can just write this down as, 3 pi, oh I'm sorry, wait a second, it's 4 and it's 2 pi plus theta over 4 and then sine Oh, I should consider writing that one first here actually. So basically I'm just writing about this one here, right? And then I will talk about this one. So it's pi plus theta over 4 and times sine of it's 2 pi plus theta over 4, and then this one can be written as 3 pi. Yeah, it's sine of 3 pi plus theta over 4. So yeah, we are having this much amount of things right here, and again we can just factor these four things out here itself, like the sine theta over 4, sine pi plus theta over 4, sine 2 pi plus theta over 4, and sine 3 pi plus theta over 4. So if we are just going to factor them out again once again, so if we talk about sine of theta over 4, so that can be written as sine 2 sine theta over 8 and times sine of pi over 2 plus theta over 8. I've just used the formula straightforward without wasting our time here. Okay, next sine pi plus theta over 4 can also written as 2 sine pi plus theta over 8. Oh, wait a second, it's theta. Pretty fine. And sine of pi over 2 plus pi plus theta over 8. Again, it's fine, and we are just heading towards some better results, right? Okay, so next we would say that, yeah, next if we talk about sine of 2 pi plus theta over 4, so that is 2 sine of 2 pi plus theta over 8, and then sine of pi over 2 plus 2 pi plus theta over 8. Okay, and finally let me just cover it in a yellow box, and then finally we are having sine of 3 pi plus theta over 4 can also be written as 2 sine of 3 pi plus theta over 8 and sine pi over 2 plus 3 pi plus theta over 8. Okay, so finally we are having this much amount of things, and now I'm just going to simplify this this thing here, this argument actually. So let's just solve them out right here with the red pen. So this can be we can say it's 4, wait a second, it's 8, and it's 4 pi plus theta. This one is, wait a second, what happened, wait a second, yeah, okay, I'm sorry, I couldn't scroll, that's why I just got scared off. Okay, and this can be written as 5 pi plus theta over 8. Wait a second, let me just check that out, because if we consider 8, so it's 4, yeah, it's fine, it's fine. Okay, so and now we can just consider writing it as 7 pi plus theta over, oh I'm sorry, it's 6 pi. So 6 pi plus theta over 8, and this is finally 7 pi plus theta over 8. You can just guess that out if you want, right? So it's quite guessive things. And yeah, let me just check that out once more. So it's 8 and 4 pi plus 3 pi plus theta, so it's 7 pi plus theta over 8. Yeah, it's pretty fine. So now we can just replace them like that, and with these things actually, yeah, we can just replace this argument with these things, and now let's just plug them back into this very equation. So basically we are having sine theta as we had earlier 2 cubed, right? And if we talk about the factor of sine of theta over 4, so it's 2 sine of theta over 8 and times sine of its 4 pi plus theta over 8. Yeah, it's pretty fine, and it's pretty like understandable, right? Again, it's the, if we talk about the factor of this one, the second term, so that is 2 sine of pi plus theta over 8, and then, well, I should consider writing this slightly here, because yeah, 2 sine pi plus theta over 8, and then sine 5 pi plus theta over 8. Okay, next 2 sine 2 pi plus theta over 8, and then sine, I think it was 6 pi plus theta over 8. Okay, yeah, let me just check that out once more, and yeah, it's fine. And finally, we are having the last factor for this kind of thing is sine of 3 pi plus theta over 8, and then sine of 7 pi plus theta over 8, right? Okay, so we are having this big chunk of things again, and now again we are having some 4 2's here, so we can just plug that out and give them a multiplication over this one. So that's gonna give us sine of theta is 2 to the 7 now, and we are here again, yeah, we are having some these kind of things. Well, let me just write that down slightly in a better way. So it's theta of sine of theta over 8, right? Okay, then sine of pi plus theta over 8. Actually, I jumped off from this one to this one, and then to this one, then to this one, and then come back to this one. Actually, I'm just moving in a order. Actually, that's a multiple of pi in order to, the first one is having a 0 multiple of pi, then first, then second, actually. So that's why, in order to get something better, so it's 2 pi plus theta over 8 times sine of 3 pi plus theta over 8, then sine 4 pi plus theta over 8, sine 5 pi plus theta over 8, sine 6 pi plus theta over 8, and finally we are having sine of 7 pi plus theta over 8. So yeah, this is the really amazing, and I should have used this color instead. Oh my god, this is really amazing. And now we are just going to generalize it, actually, because look, we are having, oh wait a second, I just used 2 here, I'm sorry about that, it's 8. So when we are having like a denominator of something n here in the argument of sine, well, everywhere is 8 only, then we were having 2 to the power 7, that is less than 1, that is n minus 1. So we can just generalize it as, wait a second, yeah, it's pretty fine. Okay, yeah, okay, so let's just generalize this. So basically sine of theta can be written as 2 to the n minus 1 times sine of, it's theta over n, the very first term here, look at this, and then we are having sine of pi plus theta over n, right? Then we are having this, all the things, 2 pi plus theta over n, and so on, something like that. And if we talk about some n terms, so that is sine of, actually this goes up to, and it's n minus 3 pi, the third last term, actually, I'm sorry, it's n, then sine of n minus 2, actually here, 2 pi plus theta over n, and finally we are having sine of n minus 1 pi plus theta over n here. So this is the generalization of that work that we did till now, right? So this, we are just getting out of all these things, actually. So all this big chunk of things, we just got rid of all the things, and we are here, actually. So yeah, that's pretty fine. Next, we are gonna do something here, actually. Well, we are just going to play around with a little bit with these things, actually, right? Okay, So next we can just write them as well. If we talk about this one, so it's n minus 3 times pi plus theta over n. So let's just do something here. N pi over n minus 3 pi and over n and plus theta over n, right? So it is pi minus, we can just write it as 3 pi minus theta over n. Oh, I'm sorry, it's n here. So yeah, we can just write that down, something like that. So, and if we talk about something n minus 2 pi plus theta over n, so that can be replaced with pi minus 2 pi minus theta over n. Eventually when you solve these things, so you're gonna have this amount of things, and if you solve this, so you're gonna have this one. So actually we just want to just generalize something actually, so that is why we are doing that much amount of things actually. So let's just consider writing this same thing, that is sine of theta to the n minus 2 to the n minus 1 and times sine of theta over n, sine of pi plus theta over n times sine of 2 pi plus theta over n dot 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 2. We can write that argument as pi minus 3 pi minus theta over n, right? Yeah, it's pretty sure here. Then sine of pi minus 2 pi minus theta over n, and finally this can be replaced with pi minus theta over n. Yeah, it's fine. Okay, and now next what we are gonna do here, so yeah, you know what, let's consider doing something here, a little bit things actually. So if we talk about sine of pi minus z here, so again I have proved these kind of relations in that video that I have recommended you to watch first. So if you have watched, that's great. So from there we can say it's sine pi cos z and minus sine z cos pi. So this is 0 because sine pi is 0 and cos pi is -1, so that's gonna give us sine z only. So basically here we are having some sort of things like that. Actually, you know what, it's pi minus this argument, so we can just write instead of pi with this argument only along with sine. From this identity we have proved this. Yeah, it's pretty fine. So let's just write that down. So it's sine theta equals 2 to the n minus 1, I'm sorry, it's sine of theta over n times sine of pi plus theta over n times sine of 2 pi plus theta over n dot 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 2. Well, again, as I just told you here, to just replace this with sine of 3 pi minus theta over n, because from this very identity we can say that. So this third last term can be written as sine of 3 pi minus theta over n. The second last can be written as 2 pi minus theta over n, and the last can be written as pi minus theta over n. That's really pretty amazing thing, because again we just used the things that we have proved in one of my videos, and that is why I'm just asking you repeatedly to please just watch that video, because that's really important. Okay, next what, yeah, so now let's talk about a term in between this one and this one terms, like I'm talking about here or here. So basically we would be having something, a term like this one. Let me just show you. It's sine theta over n sine of pi plus theta over n dot dot dot. Well, it is evident that there must be a term on which there must be having the n over 2 multiple of pi, right? So this is evident in between these two things, right? So yeah, and then dot 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 to the last terms actually, that is 2 pi minus, let me just not write the third here, rather just wasting our time. So it's pi minus theta over n. Okay, so now why did I just introduce this one here? We can just write this as sine of pi over 2 plus theta over 2. And what it is? It's the cosine of theta over 2, right? So let's just use that over there for a little bit. So yeah, so we can just write that down as sine theta equals 2 to the n minus 1 times sine of theta over n, and then we are having the cosine of theta over n. Actually, from here, let me just show you. From here we can just plug that here because everything is being multiplied to each other, so we can just replace any kind of positions. Next, we are just going to combine some terms like this one with the very last one, and we would be having sine of 2 pi plus theta over n here. So we just gonna combine this with this one actually here. So let's just do that. You know what, because again we are just going to use a property of trigonometry there. So it's sine of pi plus theta over n and times sine of pi minus theta over n. Then if we talk about sine of 2 pi plus theta over n and then sine of 2 pi minus theta over n, and then this just goes up to infinity because n is tending to infinity, right? Or else we can just write some terms. Well, not that let's not do that here for a little bit. So now we are just going to use a property here. Well, I haven't proven this one, so please just bear with me here, but yeah, if you want I can just propose the proof of this one also, don't worry. So it's sine of a plus b over c and sine of a minus b over c equals, it's sine squared of a over c minus sine squared of b over c. So yeah, this is a pretty amazing integral. I'm sorry, not integral actually. It's pretty result, and it's pretty amazing result and identity. So basically we are having a plus b over c, pi plus theta over n, 2 pi plus theta over n, a minus b over c, pi minus theta over n, 2 pi minus theta over n. So we are just going to talk about this one. So here we are having as pi, b theta, and c as n. So basically that can be represented as sine squared of pi over n and minus sine squared of theta over n, right? Yeah, let's just do that here. So we can just write that down as sine theta equals 2 to the n minus 1, right? Then sine theta and sine theta over n and cosine theta over n, just leave them alone and let's just play around with that things. So there's sine squared of pi over n as I just said you that, and minus sine squared theta over n. Then if we talk about the next one, so it's sine squared of 2 pi over n minus sine squared of theta over n. Yep. Next, sine squared of 3 pi over n minus sine squared of theta over n, dot dot dot. And that's pretty amazing. That's really amazing, guys. And this can be written up to sine squared of pi over n, and it's n, oh wait a second, n over 2 minus 1 actually, right? And then minus sine squared theta over n. So this can be written up to like something like that. And let me just use again a parenthesis here for this one also, because this is really amazing and important for a later use. Next, now we are gonna divide both sides with sine of theta over n. Well, what we are going to do is we are gonna dividing, let me just write that down the language here, dividing both sides with sine of theta over n, and then taking limit when theta tends to 0. So we are gonna do that much amount of thing here, right? Okay, So what's that gonna give us? Let me just show you. So its limit as theta tends to 0. So on the right hand side we were having sine of theta, and we have divided it with sine of theta over n, and on the right hand side we were having 2 to the n minus 1, and then wait a second. Yeah, so if we take the limit on the right hand side here, let me just show you. If we take the limit on the right hand side when theta tends to 0, so basically this is going to be 1, right? Okay, and next wait a second. Yeah, so we have divided it with sine of theta over n, so this is going to be cancelled out, and limit theta tends to 0, this is going to be 1, this is going to be vanished, this one is also going to be vanished, this one is also, actually wherever you are having theta on the right hand side, that's gonna give us 0. So basically we would be left with 2 to the n minus 1 times sine squared pi over n times sine squared 2 pi over n times sine squared 3 pi over n, and so on. So that's really amazing. So here let me just do some things here, wait a second. And so we are having here is sine squared pi over n times sine squared, let me just use a parenthesis, 2 pi over n times sine squared 3 pi over n, and this goes up to infinity. Or maybe we can consider just taking up to sine squared pi over 2 n over 2 minus 1. Yeah, it's pretty fine. Okay, so now because this is a 0 by 0 form, we just have to consider the L'Hopital rule, which says take the derivative of the numerator and the denominator. So basically it's limit theta tends to 0, we are taking the derivative with respect to theta here, and over theta over del over del theta of sine of, wait a second, theta over n, and we are having something result very fascinating on the right hand side, that is 2 to the n minus 1, and sine squared pi over n times sine squared 2 pi over n times sine squared 3 pi over n, this goes up to sine squared pi over 2 n by 2 minus 1. Oh, I think it's not, actually it's not pi over 2 here, it's n, I'm sorry about that. So yeah, okay, so now we are having, when the derivative of this one is cosine of theta, right, and the derivative of this one with respect to theta is 1 over n times cosine of theta over n. Okay, so basically when we replace, and now we can just consider putting theta equals 0, so that's gonna give us 1 over n. So basically that's gonna be n here, so n comes out to be 2 to the n minus 1 sine squared pi over n times sine squared 2 pi over n dot 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 to sine squared pi over n and n over 2 minus 1. Oh my god, that's really amazing result here. I would request you to just look at this down. Yeah, look, n can be represented as 2 to the n minus 1 times sine squared pi over n times sine squared 2 pi over n, and this keeps going up to sine squared pi over n times n minus 2 n over 2 minus 1. Oh my god, that's really amazing. Let me just use this color, because this is I'm using this color to those which are really important to us, and we just need to write that down even if we are not writing anything. So basically if we are going to divide this with this result, actually, yeah, so basically we are gonna divide, let me just zoom out slightly a little bit, we are just going to divide this result with this one, right? Okay, let's see what we are having here. So basically I'm just telling you to do something here, that sine theta over n right? And sine theta equals this one, and then n equals this one. So we are having 2 to the n minus 1 on in sine theta, and then where we were having sine theta over n, right? Wait a second, sine theta over n, cosine theta over n, and then we were having sine squared pi over n, sine squared pi over n minus sine squared theta over n, then sine squared pi over, oh I'm sorry, it's 2 pi over n minus sine squared theta over n, and that just keeps going up to sine squared n, oh wait a second, it's pi over n times n over 2 minus 1, and dividing with n, which we have evaluated something like this. So it's 2 to the n minus 1, and then sine squared pi over n, sine squared 2 pi over n, sine squared 3 pi over n, that keeps going up to sine squared pi over n, n over 2 minus 1. Oh my god. Yeah, okay, so now we can see something better cancellations here with this one and this one, right? Okay, and next we can just multiply both sides with n in order to get something like this: sine theta equals n times sine of theta over n times cosine of theta over n. Yeah, that's pretty fine. And then if we solve, like if we consider solving this one dividing with this one, so we're gonna have 1 minus sine square theta over n over sine squared pi over n, right? So we can just write the first parenthesis as 1 minus sine squared theta over n, and then sine squared over sine squared pi over n, then 1 minus sine squared theta over n over sine squared 2 pi over n, and this is going till up to, and again 1 minus sine squared theta over n over sine squared 3 pi over n, and these just going up to 1 minus sine squared theta over n over sine squared pi over n and n over 2 minus 1. Wow, that's pretty fine. Okay, so yeah, next what we are gonna do is here we're gonna take some limits that's really gonna just blast our mind a little bit, not too much, don't worry. Okay, so basically taking limits on both sides when n tends to infinity. Taking limits on both sides when n tends to infinity here. Okay, so what is gonna give us here? Sine theta. Well, since sine theta is not having any kind of n terms, so it is get rid of that. N tends to infinity of n times sine of theta over n cosine of theta over n times 1 minus sine squared theta over n sine squared pi over n 1 minus sine squared theta over n over sine squared 2 pi over n, and then this is just going up to 1 minus sine squared theta over n over, it was sine squared pi over n times n over 2 minus 1. Wow, that's pretty fine. Well, since we should not consider writing this term here because n is tending to infinity, so we don't care about the last term. But well, yeah, we did that, it's all right. Okay, so now we can consider writing something changing here. We can consider writing it as limit n tends to infinity. Well, this can be written as, n can be written as sine of theta over n, and this can be written as 1 over n, right? So basically I'm just going to write that down here, sine of theta over n over 1 over n, right? And wait a second. Well, when n tends to infinity, so cosine of theta over n is going to be 0, which is cosine of 0, which is 1. So hence this is going to be 1 here, right? Okay, so now let's just write them down here. So 1 minus sine squared theta over n over sine squared pi over n times 1 minus sine squared theta over n and sine squared 2 pi over n, this going up to infinity. Fine. Okay, so next, if we talk about this limit, let's just consider this one here. So if we talk about that one, so basically we are having limit n tends to infinity of sine of theta over n over 1 over n, right? So let theta over n equals t. So that's gonna give us when theta is, when n tends to infinity, so theta is tending to 0, right? Okay, so basically this limit is gonna be something like this. Limit as t tends to 0, so this is sine of t, and this is going to be well, we have to write t, so it's theta over n, right? Okay, so it's theta, wait a second, well, we should write n here. Well, we were having 1 over n, so it's t over theta, it's t over theta. So basically that's gonna give us theta times limit, and it's t tends to 0 sine of t over t. Again, this is an important identity which we have talked about in one of my latest videos, and this is going to be 1 when we use L'Hopital rule. So basically this limit is going to be evaluated to theta here, right? And if we talk about the second limit, that is the big chunk of things which is here, this much amount of things actually I'm talking about. So limit as n tends to infinity of 1 minus sine squared theta over n sine squared pi over n, then 1 minus sine squared theta over n over sine squared 2 pi over n, then 1 minus sine squared theta over n over sine squared 3 pi over n, and this just going up to infinity. So for that we just have to do something here, or we can just consider only one term. Let's not consider this whole series, but let's consider one by one. So we can just consider this one here, right? So basically we can just plug this as limit n tends to infinity of 1 minus sine theta over n over sine pi over n whole square, right? So what's that gonna give us? So basically when we take the derivative, well, again using L'Hopital rule, when you take the derivative, so that's gonna give us 1 over n cosine of theta over 1 over pi. Oh, I'm sorry. Oh, wait a second. Yeah. Oh, wait a second. So basically that's gonna give us theta times, wait a second, let me just use this laser pointer here. So when we take the derivative with respect to n here, n, so that's gonna give us theta of cosine of 1 over n over pi, it's over pi of cosine of pi over n, 1 over n, right? Or maybe theta over n, oh, wait a second, I'm just making a lot of blunders here. Let me just use that down. So it is basically a limit n tends to infinity of 1 minus it's when we take the derivative, so that's gonna give us theta of cosine of theta over n over pi of cosine of pi over n whole squared. So basically when we talk about the limit, so n tends to infinity, so cosine of theta over n is going to be 1 and cosine of pi over 1 is going to be 1. So basically this limit evaluates to 1 minus theta squared over pi squared. And if we are just going to plug this for all of them, let me just use a parenthesis here. because this is really important to be understand in order to get all of them correctly. So if we talk about, we have talked about this one only, so if we talk about this one, so that's gonna be theta squared over 2 pi whole squared, and this one theta squared over 3 pi whole squared, right? So basically this limit evaluates to limit of well, it is going to be evaluated to 1 minus theta squared over pi squared times 1 minus theta squared over 2 pi squared, right? And then 1 minus theta squared over 3 pi whole squared, and thus just keeps going up to infinity. So basically if we are just going to combine these two limits here, as we got theta here when we solved this one, and when we solve these things, so we did have 1 minus theta squared over pi squared times as just going up to. So when we combine all of them, so we are having sine of theta on the left hand side evaluates to theta, and times 1 minus theta squared over pi squared, 1 minus theta squared over 4 pi squared times 1 minus theta squared over 9 pi squared, and that just keep going up to infinity. And if we are just going to if we are just going to use the pi product notation, so that's gonna be sine of theta equals theta times the product as n goes from 1 to infinity of 1 minus theta squared over n squared pi squared. Hence proved, guys. So this was the Euler's proof of sine theta in terms of an infinite product, and from here itself we can say that it's sine theta over theta equals the product as n goes from 1 to infinity of 1 minus theta squared over n squared pi squared. And you know what, I have been looking to prove this down for a long period of time, but I just made guts now to prove this down in front of you all. And you know what, we can use this to prove some Euler's reflection formula or the Weierstrass product, which I have used, right? Basically you just have to plug theta equals pi z here, so that's gonna give us sine of pi z over pi z equals the product as n goes from 1 to infinity of 1 minus theta. When you plug theta here, it's pi squared z squared, so this pi squared cancels out with this one, so basically we're having z squared over n squared. Again, a very important relation here. And again, if we talk about something like this one, let's just talk about something about these things. So basically this is saying that if we take the reciprocal of these things, so this is pi z over sine of pi z equals the product as n goes from 1 to infinity of 1 minus z squared over n squared whole to the negative 1, because we took the reciprocal. And you know what, if we're just going to divide both sides with z, so that's gonna give us pi over sine pi z equals 1 over z times the product as n goes from 1 to infinity of, we can just write this down as n squared over n squared minus z squared. And here it is. You know what, this is the Euler's reflection formula, and I have proved this multiple times, I think more than 2 or 1 time actually. And this evaluates to gamma of z times gamma of 1 minus z. And hence from here we can say that if this is equal to pi over sine pi z, so hence gamma of z times gamma of 1 minus z equals the product, oh I'm sorry, I should have taken the factor of 1 over z at front, and the product as n goes from 1 to infinity of n squared over n squared minus z squared. Oh my gosh, we did a lot of things in this video. Wow. So this is going to be the greatest video I have ever made till my whole 53 or 54 videos. And yeah guys, it was really difficult to prove, and we did that. It has taken more than 50 minutes, I think. And yeah, it was pretty difficult, and we did a lot of things, like a lot. Like we just began our proof with this basic expansion and this basic rule that I have proved in this video in front of you all, with the help of the thing that I have proved earlier in my videos, with the use of e to the I theta equals cosine theta plus I sine theta. Look, this video is totally dedicated to Euler, because we are proving this one, right? We were proving this one. We did use of Euler's identity, right? Okay, next, if we talk about the very last page, so we did use of the Euler's reflection formula here. Oh my god, this Euler was, oh my gosh, what was him? He was the god of mathematics, I think. Well, again, Gauss was also known as or considered as the prince of mathematics, so that's pretty fine. And yeah, so we did that, and yeah, so we just did that using this Euler's reflection, Euler's formula here. And then we just did that sine 2 theta equals to sine theta cosine theta. We usually use this, but we don't have a proper proof of this. By the way, you can prove that out because I have shown you the proof of that. Okay, fine. Next, we just use this one identity here, as I explained you here. Actually, you can also prove this down when you expand this using the same formula that we did here. So you're gonna have cosine of theta over 2. This is a homework, a slightly bit easy, or maybe most easy homework for you. Okay, fine. So the first sine theta can be represented as 2 sine theta over 2, and cosine over 2, right? So cosine of 2 over 2 can be represented as sine of phi over 2 plus theta over 2, as I explained you here. And it's a homework for you to just prove that down by your own. And then we just did we did further factorize the sine of theta over 2 here. We did that, and then we just further factorize the sine of pi over 2 plus theta over 2, and we further did that here. So here is we are getting the result. And oh my god, well, again we did the factorization of sine of theta over 4, sine of pi plus theta over 4 times sine of 2 pi plus theta over 4 and sine of 3 pi plus theta over 4. We did, and we are having this much amount of things from all the factors of 4 things, and then we just plug them out in the equation. So we were having this much amount of things here, right? Okay, so next we just used something here, or maybe you can just write this down as slightly bit of like this actually. Yeah, okay. Oh, wait a second, it's not like that. Yeah, so basically we have generalized. I'm sorry, it's not like that. You cannot write this one, as this one. Actually, I'm sorry about that. We just generalize it here, because we were just playing with numbers, but we did play with n-1 here, as I explained you in this video. And then we just did use of this argument to just come up with this idea after using this thing. And then from this thing we did use of this idea to come up here, and that was pretty fine. And then we just combined the negative factor of theta with the positive factor of theta here. I'm talking about this one actually. So yeah, and then we just used the good looking thing. Well, if you want, I can prove that down for you guys. So I think this is the only thing in this whole video which I haven't proved yet, but still, if you want, I can just prove that down. Or maybe I would just say that prove this down using the sine of a over c plus b over c formula that we have proved. Oh, I think I should prove this down. I can do this right away. Let me just copy this down and prove this down in this video. Let's just finish it up right here. So yeah, let me just explain you slightly a little bit. So basically we are having something like this thing. So we just use that thing, and sine squared pi over n, sine squared theta over n, and then we just took some limits and theta over n dividing with. So yeah, I just explained you. And n, oh my god, this is really amazing. So you can represent n as this thing. Wow. And then we just divided it with the first, like these two things are dividing with each other, this one and then this one. And then we just take some limit, we have taken some limits when n tends to infinity, so we just solved some limits, and then we are good to go with our final result, that is this one. And then we did some playing, we did some game with this result that we got here. I think I should just prove that down here that I am looking for. So well, how we can do this? Well, we know that sine of a plus b equals sine of a cosine of b plus cosine of a sine of b. So here for our, oh my god, let me just use xy instead, because I think you're gonna confuse here. So for that case, let me just use xy. So it's sine of x, I'm sorry, cosine of y plus sine of y cosine of x. So for our case, we are having, for this one, we are having a over c as x and b over c as y, right? And if we talk about the negative part of it, so it's x minus y equals sine of x cosine of y minus sine of y cosine of x. So let's just use for that. So if we talk about sine of a over c plus b over c, so that's gonna be here, let me just use this color, sine of a over c, wait a second, a over c cosine of b over c, and then plus sine of b over c cosine of a over c. And if we talk about the expansion of sine of a over c minus b over c, and then we just have to multiply them both with each other, so that's gonna be sine of a over c cosine of b over c, just the difference is with a negative in front of after the second term, sine of b over c, and then cosine of a over c. So let's just multiply them together and let's see what we are having. So it's sine of a, let me just use a different color here, so it's sine of a plus b over c, and then times sine of a, I'm sorry, minus b over c. So that is going to give us sine of a over c cosine of b over c plus cosine of a over c and sine of b over c, and times the second thing, that is sine of a over c cosine of b over c, and minus in front actually, okay, and then we are having sine of b over c cosine of a over c. Well, this is your, let's consider this as x, oh not x actually, let's consider it as small a, and this is your small a, right? And let's consider it as a small b, so this is your small b here. So it's a plus b into a minus b, which is a squared minus b squared, again an identity. So a plus b into a minus b equals a squared minus b squared. So from there we can say that this is going to give us, finally we can say it's sine of a plus b over c times, I'm sorry, sine of a minus b over c equals sine squared of, wait a second, actually, yeah, okay, oh wait a second, yeah, it's fine. Okay, so now we can just sine squared, oh I'm sorry, so this can be written as this one whole squared, right? So it's sine squared a over c cosine squared b over c, and then a squared minus b squared, right? So minus sine squared b over c and then cosine squared a over c. So we are having something like this things actually. And then what? Actually, we were having sine squared a over c minus sine squared b over c. Wait a second. Did I make any kind of error here? Oh, wait a second. Sine of a plus b over c and then times sine of a minus b over c. So I just used that and then I just multiplied them out each other, and then I'm having something sort of things like this. I'm not sure, guys. Sine of a plus c plus, oh, I think I just made an error here and I just don't want to just figure it out because I'm slightly I'm just losing my control here. I'm sorry, and I think I should just leave it here for you guys and just find my mistake. And yeah, it's pretty fine, but it's all right. I did that, but yeah, I'll make sure to just bring a new video for that proof. But yeah, we did a lot of things in this video, so I think I should just leave for now. And thank you so much for watching this video, guys. If you got to learn something from this video, although you did a lot of things, I know that, so please make sure to like and subscribe and just come up with the next video, because I will be come up with the next video with an amazing thing. Just wait for some things, but this is really amazing. And yeah, please support me, guys. And again, if you have any kind of doubt here, so please, you just have to ask me in the comment section. I'll make sure to just reply or just answer your question as soon as possible. So yeah, it's pretty fine. Okay, so now I think it's fine, and take care. Goodbye, love you all, guys. Just make sure to be a partner with me because I'll be just getting you a lot of things like this. Goodbye, guys, love you.